Hello everyone, this is Jason from China. Today I will share about the impact modification of nylon compounding. Enjoy sharing.
We often see some people taking a hammer to a plastic product and the plastic product remains intact. Some plastics bend to break easily. Some plastics are consistent, no breaking. Even can be folded 180 degrees. Many polymers are brittle at room temperature, thus greatly reduce its applicant value. The toughen agent that give plastic better toughness, also known as impact modifier. First, let's look at the classification of plastic tougheners. For nylon modification, the main tougheners are POE toughening agent and EPDM toughening agent. In fact, the POE tougheners and EPDM tougheners that are usually talked about are grafted with maleic anhydride in the nylon toughening system. The reaction is shown below. We have seen the elastomer to play the role of the toughening parts, and the main function of the maleic anhydride is connected with nylon by active side. Maleic anhydride closed loop encountered nylon amino group. The closed loop is opened, and the amino group of the nylon is connected to the reaction link, and the water molecule is generated, so the role of the elastomer parts is toughening. The role of the maleic anhydride group is compatible. Let's take a look at POE graft MAH molecular structure. If the R is one methylene and one methyl group, then it is a butyl POE toughener. If the R is 5 methylene and one methyl group, then it is octyl POE toughener. Octyl POE toughener will be better than butyl POE toughener as it has longer chain. It has good reactivity with nylon, can be evenly dispersed in nylon, form Iceland structure, play a toughening roles, and due to its very low glass transition temperature also has a good performance in nylon ultra low temperature toughening. Let's take a look at experimental data changes of pure resin with adding DOE toughener. Now let's look at EPDM graft MAH. The principle is the same as POE graft MAH toughener because it introduces a strong polar side group on the main chain of EPDM molecule. Therefore, maleic anhydride graft EPDM can be a bridge to improve the bonding and compatibility between polar and non-polar materials. As a nylon toughener, its low temperature toughness and fatigue resistance are very superior. Let's take a look at experimental data changes of pure resin with the adding EPDM toughener. As mentioned before, glass fiber reinforced and toughening can coexist with each other. Let's look at experimental data below of nylon with glass fiber. The following is a comparison of basic parameters of the two nylon tougheners. Of course, POE graft MAH has different derivatives according to different toughening requirements, such as ultra low temperature tougheners, ordinary low temperature tougheners, high dispersion tougheners, and TPE coded toughener. Let's look at a set of low temperature toughening data. In general, the cold resistance of conventional POE tougheners is slightly worse than EPDM toughness. From the data in the above table, it can be seen that ultra low temperature nylon POE toughening agent developed now can maintain the impact strength of nylon material at -40 Celsius at 70% to 80% of the normal temperature impact. Other toughening agents are sometimes used to modify nylon systems, such as SEBS graft MAH. Its fluidity is relatively good to 2 to 9 grams per 10 minutes at 190 Celsius 5 kg, used in TPE or TPR and some elastomer modification, modified asphalt, adhesive, and so on. PE graft MAH. It is a maleic anhydride functionalized ethylene polymer, mainly used for ethylene matrix polymer modification, can provide excellent coupling effect between it and inorganic minerals. Some nylon modification even directly add PE or PP, and other polyolefin plastics, no graphene with nylon compatibility is not good, resulting in the nylon products certification. Service is not good, impact performance is not high, and so on. The toughening agent should be selected with good quality and correct application, which is very important for nylon modification to meet the requirements of nylon products.
That's all for today. This is Jason, a layman who studied nylon. Thank you. See you later.